Alrighty, so I'm a TypeScript developer. I write React, whatever. I work with Zod quite a while. I love this library, framework, call it whatever you want. It saves lives. And I also haven't touched C++ for a while, like 10 years or so. I haven't seen C++ 11 and further, so I spent like two or 3 hours just trying to recreate a min and a max type of validations that you can do in Zod in TypeScript in C++. I really hope you know what Zod is. You can, chain min and max like sequentially in the builder type of pattern. They are not builder type of patterns because, well, every time you add a new check, a min or a max or whatever lengths for numbers or strings, they create an entire copy of whatever you had before and return you entirely new instance of that string or number or whatever validation, just because you can change those different aspects like a string. You can have like a basic string schema up front, and then you create a new schema based off already existing schema you had. This is way too complex for my initial test. And again, with that out of the way, I'm going to my small presentation. In C++, again, I tried recreating the look and feel of Zod in TypeScript. I'm sorry if I violate trademark, but I did create the namespace for my string schema initialization. I do add it. Uh, I do add a minimal length validation, in this case 5. I don't provide like a custom message if something was wrong. So in this case, I'm going to rely on an internal message if something does go wrong. And I chain max validation just, just to see if our string is way too big. And before I go deeper in that, I do want to maybe say thank you to N. Lohman C++ library that can actually read JSON string, and it does allow us to get something by key, like really easily, and it does allow us to check if whatever we extracted from some key, from some object, is a string, or is it a boolean. There's also, is it a null, is it an object, or whatever. Everything we might need actually in TypeScript, in Zod, the thing provides. So if I rebuild it again and run it, there's the ambiguity of that happy parameter. Yes, it's trying to show us, is it a string? Well, 0, that means no. And of course, a boolean, yes, it is a boolean. All right, so we've got our initial parameter like extraction done. And all right, I showed you the schema, and this particular 5, this particular sample is a rather long string and a rather short string, and this cout is not even displayed over here because, well, this is that correct string. It's okay. The optional parameter that I'm returning if something went wrong, it never came. So we're not even stepping here. This is where our business logic could diverge, right? So something is correct, create a new class based on correct string or object, whatever. I don't care. In this example, the high string, well, it's less than 5, and it does display in here required string more than 5. In this example, well, it's too long and it cannot be handled by, well, me. So we do display this error. It's too much to handle. This is an internal message, I guess. Wait, I'm lying. too much to handle is a custom message I want to provide for a checker. And again, I played around with C++ 14 plus, and I do compile everything with 20, 20th version of C++, so it's all available for me. And for the last one, the things that we're passing in, the schema, is not even a string. So it says, come on, man, don't give me that. So whatever you try to do with this parameter further, just don't do it. The data is incorrect, it's not right. Business requirements are not met. The schema is saving us. So for let me just show you, okay, how it's done internally in my quick example. I know it's wrong. I know there's some stack allocation and copying structs to parent function is happening. There's some weird stuff going on, but the core idea and data allocation kind of works, and I'm quite happy with that. So whenever I call z string, so this thing in a validation, just to mimic the look and feel of TypeScript, I'm calling the helper function the string, just creating that initial z string empty struct, which can then accept a bunch of checks. And when I'm calling the min or max to add another validation, I'm calling the add check with appropriate structs that accept the lengths for minimum and maximum, and an optional error message that we want to display if something went wrong. Just like here, they don't have custom class, they don't initialize a class by name, they just pass in the shape of what they expect. This is an interface. But I decided I wanted to actually create an instance of a class because it's C++, and I use C features a lot here. So whenever I add the check, well, I push back the validation I create. I store pointer to a heap, and the vector of checks can, so this vector can accept something that could be either a pointer to max string check struct, or instance of a class or struct, whatever, or min string check. So very simple. And when I do perform safe parse, just like Zod, Zod has a safe parse method, I am checking, like, what the hell am I even passing over here? Well, in the last example, we didn't pass a string, so as string, which is available by nlochman library, well, it saves us from checking whatever is further, and yeah, we return that error. Come on, man. And everything else, if stars are aligned, well, this is handled with something here. I mean, yeah, it's ugly. Come on, look at the code. It's ugly. I'm I'm literally trying to get the type of check by like a reference type to min string check, or reference to a type of a max string check. It's similar to Rust in a lot of ways, to my liking. And what I didn't do here is I didn't create a like base class which can check something, and I never expanded on top of other class to make overridden class, because I don't like inheritance actually, and this is a nice way to composite stuff. But anyway, maybe this is too much of code, but it's a small example of possibilities, right? To get something varying from the list, and as a result of these checks, return something of optional nature. In TypeScript, this would be question mark, like return something, question mark, or like or null. So return this particular shape or null. In this case, I decide to use optional error message. And again, it's located on the stack. And if we didn't provide initialization of a check, it does see, all right, if we didn't pass anything, it creates something right on this spot. It's not wrapped in auto pointer so that it's immediately returned like or destroyed when it's out of scope. It's copied to the parent function. I don't care. This is just the way I did it. And that's pretty much it. Optional, varying types kind of make me allow me to do this. And yeah, these checks are so much simple. What else? I didn't create the entire object check like Zod can, because this would be too much work. Object something. Oh. Yeah, there is a possibility to create object with key, which is a string. I could possibly create a method to accept like a tuple. C++ has a tuple now with a key of something, and further checks for string that I already have, but that would be too much work. But the possibility is there. So technically, I like the fact that C++ can look like a scripting language now with just these simple approaches. This is my schema. If it's correct, then pass it further to create your class. And I actually don't care if there is a class or a library to do just that. I am testing shit out and flexing that long forgotten C++ muscle. Cheers.